So
it's Thursday, 2 p.m. It's time for our very popular IoT webinar.
hello.
Hello.
Good afternoon for everybody.
Yeah. So, Vita, if you be so nice, please start the presentation.
Okay.
Because I want to introduce our friends from a company called Filamentum. Because as a Liverpool football fan, I'm a big fan of the song "You'll Never Walk Alone." And today we will not walk alone. We'll be with our friends. And please, next slide.
Okay.
As you see, Josef Dolecek, CEO, and Martin Beran, 3D print expert from Filamentum. Hello, guys.
Hello, hello.
It's perfect. I'm Alan. This is Vita, and today we have one special topic, and it's 3D printing. But I'd like to start with the company HARDWARIO. We organize this event, this webinar. As you already know, we focus on hardware. And what hardware? It's is here? No. Because yes, we have some experience, and we focus on low power devices for Internet of Things with low power wide area network technologies inside. And we cover all phases, not only design, but manufacturing too. In areas which we call industrial IoT, in the Internet of Things within industry, and of course, our big passion and mission is STEM education. But today, as I already mentioned, we have a nice topic, 3D printing, and how to use 3D printing in Industry 4.0, in industry, and proof of concept in industry. Vita, if you can take over this presentation and tell us more about framework and continue with these four phases.
I will do so. As far as you know, who are watching our webinars frequently, we are working in the framework when on the first phase we use what we call realize. We will create some theoretical background for all of us to be able to move to the next session, which is called experiment, where we will show you something really practical. And after the session of experiment, we will have a session called apply, when we are showing the real realization from the world, from the field, what has been done. Today we have prepared special apply from guys from Filamentum, and I'm very looking forward to this session. And the last session is called reflect. This is a time for answering the questions, repeating what we have learned today. And if you are talking about the questions, feel free to ask for everything you need to know. Do it via the chat window in the YouTube. And if we will be able to do it, we will answer it on fly. And on the end, we will have 2 or 3 questions to answer live from me, from Alan, maybe from guys from Filamentum. And it will contain approximately 1 hour, maybe less, and we will have amazing time today afternoon.
Yes, so one more time, we will learn and we will do some experiments, and we will show you how to apply what we learned today in some real life industry projects. And I'm so happy that guys from Filamentum will help us in all 3 phases. But let's start with theoretical base and realize what the 3D printing is all about.
Okay. I would like to start with different words we were not talking about the additive manufacturing. Don't worry, this is how the 3D printing is called in industry environment. And it does mean there is something what is manufactured by adding a small piece of material, some layers, as you know it from the 3D printing. Very thin layer of material is added all times, then there is a result, we call it object. To make clear some abbreviations we will use, we will see 3, and we see them here on this slide. AM means additive manufacturing. This is an umbrella of the topics we are talking about today. And then there will be FFF, which is fused filament fabrication. And sometimes it is called FDM, which is almost the same. It means fused filament fabrication or fused deposition modeling. As I said, 3D printing. So don't be trapped, don't be confused during our speech. Someone of us will use different words. So it's additive manufacturing, and everything is about 3D printing. What are the advantages of 3D printing? We can imagine all of them, but in general, we are able to create some prototypes and temporary parts, which is very useful. The prototypes are used when we think about something new and are not willing to wait until it will be created by some machine or some special construction guys, and we can prototype what we want. Or temporary parts, something when broken, we have no spare part available, so we can create this temporary part for a while. 3D printing is useful for fast production. When we need to have something very, very quickly, we will do that. In HARDWARIO, we do use it for the boxes or for some holders for sensors we do use. So this is fast production. Reliable materials, it is the topic which will be covered by guys from Filamentum, but nowadays materials in 3D printing are really amazing. You can imagine almost everything is printable. We will see the word almost after that. And there are, of course, the fast return of investments. It means we started very quickly, very easily, and we can receive the money or the benefits from this activity.
Yes, and speaking about fast production, we all know what happened during the coronavirus. So how 3D printing really helped in many cases in healthcare and all these affected areas. So that was a perfect example how we can use 3D printing.
Yeah, this picture shows the areas where the FFF for industrial use is used, the prototyping, maintenance, and low series production. Everything what you see there are real products printed by guys from Filamentum, so it's really used. What are the key parameters for application for adaptive manufacturing? We need to do it fast. So fastness is one of the parameters. The idea we are creating needs to be easy to draw and produced immediately. It means if we are talking about something really, really difficult, the AM wouldn't be the right choice. But if we are talking about some simple things, it is a good choice. We have new options. We have possibility to produce the shapes which were impossible to make in the past. Why? Because we don't need to molding, we can model it. It's pretty different, and we can build it from the flat to very complex shape. We will see there will be some materials which can be used like a support and will disappear after some activity, maybe with the hot water or something like that. So we are able to do it. And of course, the prototyping and scaling we talked about slide before. We have a variety of options to find the optimal solution. Let's talk a little bit about the principle, how the material extrusion technology works. This is what everyone can imagine when we say we will 3D print it. Yeah, that's something we can imagine. There will be something which press the material, the plastic on the pad and builds the structure. So why is it possible? Because on the top of the picture, you can see the exterior where the material is fused, and this material is pressed through the heated nozzle, which draws the layers of the filament on the object we are printing. This is the really example how it is designed, and of course in reality it is much difficult, but this is the principle. And now one of the most difficult questions in 3D printing is how to choose the right material, because nowadays there are plenty of materials which can be used, and every application, every model needs something different. So we have to follow the application requirements. What we need to do? Must it be a water resistant, or must it be a chemical resistant, or must it be resistant against the temperature? Every time it is a different material we will use. We are all, of course, limited by printing technology. We have 1 or 2 3D printers in regular offices, so it's necessary to have the material which we are able to print, and we need to follow some parameters. You can see there is a clickable link, a guide for material selection, which leads to the site of guys from Filamentum, where is a very nice guide how to choose the right material for your purposes. I will not open it because guys will talk about it after a while a little bit. So feel free to use it whenever we will send you follow-up of this presentation. And let's see what challenges in modeling are here. You can see the triangle on the bottom right corner, which says there is something what the application is requesting. There is something what material is providing, and there is a trouble or problem or how to print it, the printability challenge. All these 3 challenges needs to be considered during the designing the model and choosing the material in one time, and needs to be balanced, well balanced. Martin will maybe talk about it after a while, but keep in mind this is the discipline, not only to choose the right color of the material, but think about how we will print this result outside. Materials for extruding 3D prints. I would like to ask Josef to help me about the materials because he is an expert. So Josef, slide is yours.
Yes, thank you very much to HARDWARIO for the opportunity to join the webinar. This slide simply is divided into 4 groups from my point of view. The first group are common solid materials. The materials which were the first materials the technology adopted. So people who remember the real beginnings of the FFF technology, they have in mind materials which are still used in common: PLA, polylactic acid, PETG, ABS, and ASA. The common sign of those materials is that are easy printable. There are no special features. Some have lower fumes, but the main task is to be able to print without any issues. Also for people who are not so familiar with the technology. The second group I'd like to mention are engineering solid materials. Materials performing better than the common solid materials. You can imagine the materials with a higher temperature resistance, a higher loading impact, better mechanical properties in general, also in high temperatures. So there we have different kind of nylons, nylon 6, nylon 6/6, nylon 12. We have vinyl, which is PVC. We have PVDF, polyvinyl fluoride, with extra chemical resistance, peak, and of course the last type of engineering materials are composites based on different polymer metrics and combined with special fillers like carbon fiber, aramid fiber, glass fiber, etc., etc. You can imagine natural fibers as well. The third and very important group of materials are all flexibles. Why important? Because the shaping of the flexible materials in case of using 3D printing technology is much affordable than in case of milling by standard subtractive milling. So in this group we can find TPE, thermoplastic elastomer, TPU, thermoplastic polyurethane, PEBA, with extra resistance to chemicals and temperature. The fourth group are specialties. So there is a lot of different point of view. What does it mean? Specialty, from my point of view, are the materials with some special feature. Electrostatic dissipative for printing parts for production of electronic components, flame resistant polymers for usage in production, radiation shielding, antibacterial, and etc. Also based on different polymer matrices. And the last one is called support materials group, where you can find the material which is printed to be just a support for building material. So there you can find PVA, polyvinyl alcohol, which is soluble in water. You can find Foxel material soluble in hydroxide, and breakable HIPs, etc. Helping support materials helping print difficult parts.
Okay, thank you, Josef. And we'll move to another slide, which will a little bit shows how 3D printing is used here in HARDWARIO. How does our tool chain looks like? We have a 3D printer here. We are using a software which is called OpenCAD for modeling. Why we choose the OpenCAD? Because it is a software which is multi-platform. You can use it on every operation system we use. It's programming-like oriented. It's a very important point. Other CAD softwares are used from, let's say, graphical point of view. We do use it like a scripting. If we are willing to create the cube there, we will write the script cube. I will show you then in an experiment, and it helps us to provide the data for our friends in makers and for guys who are willing to print HARDWARIO kit boxes and enclosures. So we have stored this data on GitHub. How the OpenCAD looks like, you can see the scripting area on the left side. Yeah, if you will look on it, and you can read there is a cube, there is a cylinder, rotate, or some programming language style, how to create a car, which is possible to see in a rendering output area. You can see it on the right side, and this is the result of our work. And on the bottom there is a console window when we are able to see some errors or something like that. So this is about the OpenCAD, and because it is very often the question what the file formats are used in 3D 3D printing. We have the file formats here. The most common format for 3D printing is STL, which describing how the model should be printed. This STL file is a product of the modeling. Then this STL is imported to the software for the 3D printer, and it creates something what is called G-code, which is a numerical control programming language, which says to the machine how the model should be realized. In case of 3D printing, how it should be printed. If there is some different machine, how it could be CAD. So this is STL and G-code. There are some new or newer formats. So one is called VRL, which is virtual reality modeling language. It's a newer format, and the difference for STL, the main difference is it contains the coloring. In case of STL, there is a single color only. In case of VRL, we can have more colors there. And if the printer is multicolor or multi-material printer, then it is easily to operate. And yeah, AMF is an adaptive manufacturing file format. This is XML-based format. It is not so spread yet, but like we like XML for everything, maybe it will be our favorite in the future. And the last but not least file format is STEP. The STEP is a standard for exchanging data between CAD systems. So if we create a model in one piece of CAD software and need to transfer it to another company for some activity, the STEP is the good way how to do it. And STEP is written in ASCII, so it is human readable structure, but this structure is very difficult, but it is possible to read. Okay.
So great. So that was a theory, and we learned something. Now we can use this theory in our experiment. Mm-hmm. And as you told me a few minutes ago, there's some change.
I have a little bit surprise for guys from Filamentum, because my OpenCAD has crashed on my
and this is perfect. This is what I like the most. That during the webinar, there's a situation like this. So we will skip the experiments and we'll start with experiment with Filamentum, if you don't mind, guys. Yeah. If you are ready. So we will skip this first one. Maybe if you go, we will create some time for Filamentum. And later we will show you how to print some platform for ABB box, and we are using for our HARDWARIO kit. But now it's time again for Filamentum, and they will show us a holder for Dallas thermometer, which we are using in many projects, because it's a very popular thermometer, external thermometer, and it's easily connected to HARDWARIO kit and IoT hub. So are you ready, guys, over there? I will unmute you.
Yes, of course.
Thank you.
Okay, so our goal was fix the thermometer for measuring temperature in range from minus 25 degrees of Celsius to 80, 100 degrees. So we used Fusion 360, which we used for modeling. Also, I would like to introduce you a little bit into Slicer and so on. And also, we need a 3D printer. Maybe I would ask Mr. Dolecek, and he can tell you why we choose Nylon FX256 for this application. So I will give him word.
Perfect. May I ask colleagues from HARDWARIO for the proper slide? Hello? Okay, thank you. So the next one, please. Perfect. Thank you very much. So, as Vita said, we have the comparison chart. We have the chart of material comparison on our web page. So it helped us to choose the proper material for printing the holder for sensor. Because the environment where the sensor is expected to be placed is industrial. The tube will contain probably hot water, so the maximum temperature is expected to be 100 degrees centigrade. There would be for sure some tension in the model after placing on the tube. So therefore we choose nylon FX256, which is a long chain polyamide based 3D printing material. Is based on PA12. It has excellent mechanical properties. It's crystalline polymer, so it's durable, it's tough. It has excellent impact resistance, also in minus temperatures. It's chemical resistant and absorbs less moisture than other polyamides like PA6. And also is safe for food contact, so can be also placed in food production industry. So next slide, please. Yeah, there is all those features are in short term. When I mentioned that nylon is the material which is not a common material for printing, so it needs a bit experienced user who can fight with warping in case the printer is not closed in printing enclosure.
Mm-hmm. Okay, so now I will share my screen to show you how we proceed. Okay, now you should see my screen. As I said, we used Fusion 360. So we modeled part of the tube. And also we add a thermometer according to measurements and the technical data sheet of the thermometer. And then we add a cover which holds the thermometer in place with perfect contact with the tube, and is easily replaceable if the thermometer breaks. So it's connected by zip ties. So there should be fine for quick and easy change. As we choose nylon FX256, there's some basic tips to model for a 3D printed object. We recommend to use rounded corners for touching build plate, because sharp corners increase the internal forces when printing due to crystallinity of nylon. So is it better to round corners and so on? And also, if you are modeling thin walls or something, it's always good to count with layer nozzle size. So if you are using 0.4 or 0.5, you have to use the parameters for walls in 0.4, 0.8, or 1.2 millimeters, always according to your nozzle. Okay, so this is the model of the cover of thermometer. We can export the body, and I always say export from these CAD programs in the highest resolution as you can, because it gives you a better surface, no triangles in the surface, and so on. So okay, now I will show you the slicer. This is we will print on Zaribo 320, which is a good printer we used in our lab. We have lots of printers in our lab because we testing all of the materials in development and also from production batches to be sure that they are okay and they are in high standard quality. So we have a model here. So we don't need something special. The basic layer height, 0.2 millimeters. We have selected our nylon FX256 material profile and the printer. 20% for infill is enough because the part is not under big stress, just from the hot water maybe, and so on. And what is good to mention is always bear in mind the orientation of the printed part. If you know the load, the direction of load which the part should have, always place it perpendicular to the forces on the layers. It's better. It's have better mechanical properties in this way. Yeah. Okay. So we are printing into nylon. I recommend to use Beran. So slice, and we have a sliced object. Put the G code on the card and in the printer. I have used photos from production we have already printed. So this is the printing final product. This is how it looks. Yeah, and this is mounted on the tube. So due to zip ties, it's easily removable and changeable if you have a broken thermistor. So I think it's good, and the materials properties match up our application. Okay, so I think that's all from me.
Sorry, I was mute. Sorry for that. Thank you, Martin, for your presentation. It was very nice, and we are happy we have a holder for a temperature sensor.
Yeah, it's always perfect when we are doing something which is really we can use immediately. Of course, we will share it with our friends, our partners, so you can use it in your projects right away. And you will get, of course, links in webinar follow-up. Great. So now it's time for experiment number 1.
Yeah.
And it's all about something which is stored in this box. Usually call it ABB from this big guy company. And we are using it for in many projects. but to fit our hardware kit, we needed something special, and we call it base platform. So now you are sharing.
I do. So first of all, what is the goal? The goal is to show you how easy it is to get the data from our GitHub link, and
you're sharing this one. You know, you know that.
I know that.
Okay,
I do share the GitHub. Sorry, I will go here. And the link in the presentation you will receive leads directly to this page we called enclosures, which shows what is necessary to have for providing the platform. You can easily get the file which is called HARDWARIO platform scat, which is this one, and I have it here inside OpenCAD. You can see this yellow part is the platform, which is similar to one which is on the screen, and I will show you very briefly how we do that and what can we do there. There are some magic characters which are called modifier characters, which can help us. I believe you see them on the left bottom corner, which can help us debug somehow the code of the 3D model. Yeah, I have element which is called node screw here, and if I mark it with the hash and will preview it, you will see there are the red cylinders which shows what is highlighted, and I can use another one sign which is called %, and again make a preview. And now I can see these parts which are another holes in our platform, which seems to be transparent. And why is it important? When you are doing something with the position of the holes for the screw in the OpenCAD, it is done like you can create the cylinder which is negative. The cylinder is not there. You will different this part. So you can highlight the node screw, and now we need to move it a little bit. So I will move it plus one millimeter. Again, I will refresh it, and maybe you saw it. It jumps for 1 millimeter in x-axis alignment. I will do it a little bit bigger to be more better visible. Yeah, you saw it. It jumps. It does something else. It somehow causes the part of the other parts will be broken, because the node screws itself is something what is called module, and we can see it. We can find it. Node screw, and now there is a module which is called node screw, which is a definition of this node. Why this is there? Because we do it repeatedly, so we can use it as a subroutine in programming language. So that's why our guys love this software, because they can program almost all the model. And on the end of the work, we have a slightly different structure. We will just render it. It will take some time. And then when there will be 1000, so we have to wait a little bit. So now you can see the holes are outside of the platform. There is some small scratch on the platform, and we can easily save it to the STL file. I call it HARDWARIO platform 1 STL. Ta-da! And now I can go to my 3D printer and print whatever I want. So that's easy. The OpenCAD is, and of course it has a lot of features, and it is let's say electronic kit for making the kits. And we can talk about it for more hours. If you wish, give us a note, and we can prepare something more important.
Definitely. So we can go back to our presentation, because I think that it's the last slide in experiment. All right.
It was first, but it is last.
So you can go to to apply and go back, please. You are so
sorry,
fast, so fast. Because we learned this theory, we do 2 experiments. Thanks again, Filamentum, for your experiment, and we show that it's not that difficult to model something very simple, like a platform for IoT kit. Now it's time to show you that there are some real use cases in industry, and because we are not experts in 3D printing, we are doing this just because of our kit and our maker's world. But Filamentum is the right partner to show you some nice realization. I can't wait to hear about Rolls-Royce case study. So back to Filamentum, guys, and it's your time to show us who you are, what do you do, and what are your best case studies.
Feel free to call me when you need to move to the next slide.
Okay, so firstly, something about Filamentum. We are a younger company. We were established in 2012, 8 years ago. The younger team with a keen approach to polymers and amazed by new technologies. So we entered the 3D printing materials market in early stage with new ideas. We came with different colors, based on the rail scale. So it was first standardization of colors in material for 3D printing industry. It's a history for us, let's say, because we found industrial 3D printing more difficult, demands for materials as our playground. Plastic is fantastic, and we like playing with different plastic. So now we feel our focus in materials for industrial use mainly. If you open our web page, filamentumindustrial.com, you can find plenty of case studies from industry. The 3D printing is a fantastic that you have a tool, you can immediately transform your ideas into reality. So if you are not afraid to do that, you can get a fantastic result like the case studies I'll show you now. Please move. Yeah. This is what Alan was talking about. That's the use of PVC, of vinyl 303 from Filamentum in a Rolls-Royce company. This is the company producing jet engines in Great Britain. It's not the car maker, it's a jet engine maker. And you know, the aerospace industry has a really hard conditions for the parts used. So the parts are produced also with the special technologies. In this case, the task was to find the material for covering parts during plasma coating. The parts should be coated in some area. In some area must be covered, and the environment is really hard. It must resist up to 400 degrees centigrade for short period, but there was a problem to find the material which would resist in a long term. So they tested successfully our vinyl 303, which is the first commercially available PVC material in the world. May you please move the slide? Thank you. There is a picture of from the production. As I said, it must resist to 400 degrees. It must be a durable and long life material. As you know from home appliances, like tubing, covers of the roof. The PVC is used in those applications successfully. It's a fantastic material with one big advantage. It's self-fire distinguishing. So it can be used also in this direct plasma coating. Next slide, please. Yeah, this is the second case study from a company Rotorama. In the Rolls-Royce case study, you saw the usage of 3D printing in real production as tool manufacturing. Here you have case study showing how is used 3D printing and the materials from Filamentum in prototyping and small scale production, as was mentioned before. So company Rotorama produces racing drones. They have a special requirement for the materials because drones are small but very fast. And Rotorama used also a camera hold it on the drone, and the task was to print a holder. So they have chosen the material from Filamentum thermoplastic polyurethane TPU flex fill. Next slide, please. And use those facts. It's a flexible material with a high level of elasticity. It has a perfect interlayer adhesion, no warping, so the printing is amazing also for unexperienced users. And it has fantastic chemical and abrasive resistance. So you can see the final part which can be mounted on the drone. The ABS extra fill is another story. The company knew that they need the part which would have much better mechanical properties to be able to last in those conditions. But ABS was used for prototyping. So they printed the parts. They proved the shape. They proved that the model is correct. And then the final part was not 3D printed, but cut milled from carbon fiber resin, reinforced resin. So you can see if all those three application of 3D printing in industry: small scale production, prototyping, and maintenance or tooling. Next slides. Yeah, this is what I was talking about. Here you can see the picture of the final product. So I forward words to Liberec.
Okay, thank you, Josef. I was amazed by the Rolls-Royce and, of course, about the drones because it's something what the guys as me are keen on. And now it's time for reflect a little bit. Maybe we should start with, we have a time for 2 or 3 questions. Lukáš, did you have the chance to see some important question there in the chat?
Of course I do. I have prepared 2 questions for you, Vita.
For me?
Yes, it's for you. The first one is from Uri, and he asks if there is some need to learn or know some type of scripting language.
I don't think so. It is, let's say, kind of English because the cube is cube, the cylinder is cylinder. So it is not so difficult. And the cheat sheet I showed you helps you all the time. So the only thing you need is to have a geometric imagination how to the objects of a sphere, cube, and cylinder, or whatever you can imagine, will interact, and what is difference with what. So this is the most difficult part, but it is not difficult to code it.
Okay, thank you, Vita. And the second question is from Camilo, and he asked about experiment number 1. And he asked about the best approach to print material, slicer parameters, etc. If you can answer it.
Could you repeat the question because I didn't get it well?
Yeah, of course. He asked about the best approach to print the experiment number 1. So some advice about material or slicer parameters.
Yeah, we do print it from PVA and simply transfer this as STL file to our printer software, which is from Prusa, and there is nothing special. Everything is prepared, so just run and print. Or print and run. yeah. I don't think there is something special.
It's much better to start printing and then run.
Yeah.
Otherwise, you will not finish the job. Okay, thank you, Lukáš. Thank you for your questions. And as we said, in the beginning of this webinar, we'll answer the oral questions during our follow-up period. So tomorrow we will get all these questions and answers. So now it's time to tell you a little bit about partnership. And nice example, Filamentum, but we can offer a little bit more, not only to companies, but entrepreneurs too, because we do share opportunities and we can see a lot of opportunities in industry, IoT in industry. It's much better to focus on industrial IoT than this do-it-yourself home IoT projects. This is what we love, what we do. We do many experiments in our homes, but when we talk about business, the business is in industry. That's what even Filamentum showed you, that even 3D printing has a nice, can see a nice opportunities in industry. So we share opportunities, so we can give you some support, of course, technical support, marketing support, and it's all personal, no bureaucracy at all. So just contact us and we will show you how simply we can start our cooperation. There is one reason you just consider to be our partners, our friends. It's all about No Worries IoT service. If you can go to another slide. We are, oh, no. So maybe Lucas, where, okay. So, okay, no.
On the end?
Oh, in the end of this presentation. Yes, so we prepare something we call revolution, and it's a typical disruptive innovation in industry, and it's combination of technology, business model, price model, all this together, and we will share it with our partners very soon. You can register already on noworriesiot.com for more information, and we'll inform you what this is all about. So this is all about partnership, and we are in the end of this webinar. So Vita, what have we learned today?
We explained what the additive manufacturing is. I believe some of us didn't aware about the additive manufacturing itself. It was very nice to know it now.
So it's AM.
It's AM.
And there is no PM.
No.
So it's like
no. Additive manufacturing is AM, only morning.
Yeah.
We have learned where the additive manufacturing is useful. We saw some examples. We saw advantages of this, so we know it. We saw what the challenges for 3D modeling are in front of us. We remember the triangle of material application and printability, so that's really important. Now we know how to choose the right material. And on the end of this presentation, we will share with you after the webinar. You can see an amazing table from guys from Filamentum, where a lot of information about materials are stored. And we know there is a good guide on Filamentum webpage. So go there, choose your material. We saw how the OpenCAD is used here in HARDWARIO. It is really easy, and if you are a programmer, you will love it. And we saw amazing case studies about Rolls-Royce and Rotorama, which were produced by guys from Filamentum, who showed the second experiment, which was first, and it was about creating the holder for Dallas thermometer. So we have a nice holder now.
Yeah, so definitely it's something very, very useful. So now we know that 3D printing is not just about to print Eiffel Tower or a frog.
Yeah,
that how was in the beginning. It can be really used in nice projects. Great. So it's 3 p.m. So I want to thank the team. Vita, thank you so much.
You're welcome.
For preparation for everything. Of course, I'd like to thank our friends in Filamentum, Josef and Martin. Thank you, guys.
Thank you very much, guys.
Thank you so much. And of course, Lucas, hidden somewhere and trying to answer questions. Thank you so much. So what about next webinar? We will give you some time to relax, to enjoy your summer holiday. And we will be back September 17. And we'll talk about this No Worries IoT service. We'll show you the projects and case studies, everything. But we will see, the main information is that we will be back in September.
Yeah.
Thank you again. Have a wonderful summer. Bye-bye.
Thank you for all.
Have a great time.
Bye-bye.
Bye-bye.